All right, guys, let's finish up the videos for Chapter 9, Section 1 with a couple of monster factor and cancel problems. So, pluses and minuses all over the place. Pluses and minuses should tell you I get a factor. So x squared is x squares, and even the upper left corner is an x cubed, and let's start with that guy. So number 11 up here, x cubed. Do you recall anything unique about the factoring for a perfect cubed? I hope you do. It was a small parenthesis followed by a big parenthesis. If I'm going to get x cubed, I need an x and an x squared. Small one in the small parentheses, big one in the big parentheses. If I'm going to get 8, I need a 2 times a 4. Small one in the small parentheses, big one in the big parentheses. Take what's in the first set of parentheses and times them together. Soap, same, opposite, always positive. Done with the upper left corner. Moving on to the bottom left corner. Not a cubed, so I just got 2 regular old set of parentheses. X squared, x and x. 9 is 3 and 3. To get negative 9, 1 plus 1 minus. That was called a difference of 2 squares. Now, in the interest of space and time, I'm going to point out to you that if you watched the last video, you would know the rule they taught you way back when you were little for fractions, for division of fractions, was to flip the second one, the reciprocal, and change 2 times. So I'm going to go ahead and flip it as I write it. So I'm going to factor this upper right corner, but I'm going to write it in the bottom because we know it's going to get flipped. Feel free to not skip this step. Those are pretty bad parentheses. Let's try again. Not a whole lot better. All right, x squared, x and x. I'm trying to get a 10. Pretty likely that's going to be 5 and 2. Nothing but plus signs in that upper right section. So x plus 5, x plus 2. So I got that guy factored. So this guy, again, I'm saving a little space here. Maybe this is something you shouldn't skip, but I'm getting tired of writing, to be honest with you. So reciprocate means the bottom has to go to the top eventually, so I might as well do it now. X and x, 5 times 3 will get me the 15. Positive 5 and negative 3 will get me the negative 15. And as always, you can double check these by doing the outside-inside thing. Well, what's the point? The point is to find matching binomials. I see an x plus 2 down here and an x plus 2 clear up here. I also see an x plus 3. Whoa, wrong one. Let's try that again. I see an x minus 3 and an x minus 3. There we go. Now, the very first fraction we did in the part 1 video did not have multiply. It was just one fraction. And there was stuff on the top and on the bottom that we canceled. They don't have to be corner to corner. So anything on the top with anything on the bottom, as long as it's matching, you can cancel. Doesn't have to be corner to corner. So what's left? Well, the only thing that's not crossed off on the top is this guy. And the only thing that's not crossed off on the bottom is this guy. Now, if you're thinking about factoring that top that's left, I'm actually proud of you, but I'm going to tell you you're wrong. So that was just one of those things we learned along the way. If you do a perfect cube factoring, the little parenthesis, big parenthesis thing, then that guy was done. It didn't have a second step to it. So even though that kind of looks like the numerator, the top of this fraction that's left would factor, it does not. And since I'm left with a binomial on the bottom and a trinomial on the top, I cannot cancel them. They must be matching binomials, matching trinomials, etc. So that guy's done. So let's be honest, if you were good at factoring, that actually isn't that hard of a problem, even though it looks like it's crazy. All right, last problem, number 12. Let me scooch this over, give myself lots of room. All right, I'm going to try something right now that may pay off later and it may not. Do we typically see a problem written as 10 minus h or h minus 10? It's usually flipped the other way around. So I'm going to go ahead and do this. I'm going to multiply the top and bottom by negative 1. And then what would happen here? Well, what would happen to the negative h? He would become positive. What would happen to the positive 10? He would become negative. So in other words, it's more likely that I'm going to use an h minus 10 than the other way around. Now, that might not pay off, but it didn't hurt either. Times 3h is a monomial. I cannot factor him. On the bottom, it says h squared. That should tell me I can factor. H and H. 3 and 4 will get me the 12. A pair of negatives will add up to that negative 7. Now, I could go ahead and reduce this guy and worry about that last one, but here's an option. If it's a division problem, you know at some point you're going to have to change it to times, and you know at some point you're going to have to flip it over. So we can go ahead and do that right now. You could have saved that for later. Now, again, here's an h squared. So I know that guy's going to factor, and I'm going to go ahead and factor him. So I am flipping the fraction and factoring at the same time. Hope that's not throwing you. 6 and 5 will get me 30. Pair of negatives. Oop, wrong combination. See, even I do make mistakes as well, guys. So that would not have added up to the 13. It was in the middle. In fact, that's going to give me a chance to give you a little hint as to how to make the factoring go a little faster. Before I write in what times what is 30, and I should have said this already, search around down on the bottom here. Notice that I got an h minus 10. Well, the only way I'm going to be able to cancel an h minus 10 is another h minus 10. Notice down on the bottom I got an h minus 3. The only way I'm going to be able to cancel an h minus 3 is if I have another h minus 3. So that at least helps you get to the right combination for factoring. I had 6 and 5 a minute ago. So if you look on the bottom, I don't see any h minus 6s and any h minus 5s. So this is way less likely to be the right factoring. So that ended up being a good mistake on my part. All right, division is gone. It's been flipped. All the factoring's been done. Now you just get to cancel. So you can think of this as one gigantic fraction bar. So the point is to cancel something on the top with something on the bottom. It doesn't matter where. So the fact that this h minus 3 is in the middle, this h minus 3 is on the end, it doesn't matter. One's on top, one's on the bottom. The fact that the h minus 10 is clear over there, and that h minus 10 is clear over there, doesn't matter. You can cancel them. So the only binomial I have left is the h minus 4. I'm stuck with him. But the other two guys, they're monomials. So I could always do this. Reduce that 3 and reduce that 6. 3 goes into 3 once. 3 goes into 6 twice. Just be careful. That guy's left over. That guy's left over. That guy's left over. And the h minus 4 is left over. So even though I did make it into a giant fraction bar, it still was multiplication. So what's left on top? I get a negative 1 times that h. Negative h. And on the bottom, I have this 2 left, and I have this h minus 4. So I'm going to distribute that. And I got 2h minus 8. And that's it. So even though that problem looked like it was going to be crazy difficult, it actually wasn't that bad. But the key is factoring. And let's be honest, we have harped on you all year long about getting good at factoring because we use it over and over again. So I'm going to say it again, and I know you're probably ready to kill me for this, but the top of this answer is a monomial. The bottom of that answer is a binomial. Someone's going to want to cancel those h's, but you can't do it since they are not matching binomials. All right, guys, that is the conclusion of Chapter 9, Section 1. 9.2 is more algebraic fractions. I know you're excited, but that will be add and subtract. And add and subtract is a little bit tougher because add and subtract involves common denominators. So if you suffered through my 3 videos for this section, I highly recommend that you check out the videos for Section 9.2. Thanks for watching. See ya.